Hey, this is Mr. Weisfeld again. We're talking about velocity and acceleration, and we're doing it on velocity versus time graphs. There's a question type that you might see on the AP Physics exam that comes from N-typers, N-T-I-P-E-R-S. It stands for Newtonian Tasks Inspired by Physics Education Research. What you'll get is some selection of information, and then you're asked to rank the information by some criteria. So let's read about this for a second. The graphs below show the velocity versus time for 6 boats traveling along a narrow channel that runs east to west. The scales on both axes are the same for all of these graphs, and east is positive. In each graph, a point is marked with a dot. Rank these situations on the basis of the acceleration of the boat at the point indicated. Okay, so acceleration equals change in velocity over change in time. In this case, it looks like all of these graphs have, all these graphs are straight lines. Straight lines on a velocity time graph mean constant acceleration. You can see that from this equation here. Furthermore, we know that if the slope of a graph is positive, that means the acceleration is positive. So this one here is rise over run, rise 1 over run 2. That's basically an acceleration, something like 1/2 unit. This one right here is 1.5 over 3, 1.5. I'm doing rise over run. 1.5 over 3, 1, 2, 3. This one right here, although the velocity is 0, what we're trying to do is acceleration. Acceleration is still negative, so this is a negative velocity. This is rise over run, let's see, -4 over 3. So that's the acceleration. Remember that all the accelerations on these are the same because the lines are the same. This one has a rise of -2 all over 1.5. This has an acceleration of 1 over 1, 2, 3, 4, 5, 6. 1 over 6. And this one has an acceleration of -1 over 1, 2, 3, 4, 5, 6. Okay, so the basis of the acceleration. Rank these situations on the basis of the acceleration at the point indicated. At the point indicated, velocity may be positive or negative, but acceleration is constant. So here we go. So the greatest acceleration, the greatest positive acceleration is, I think, 1.5 divided by 3. Let's just double check here. .5 divided by 3, 0.5. Let's try the other one. Well, the other one was 1 divided by 2. And then -4 divided by 3. And -2 divided by 1.5. And 1 divided by 6. And -1 divided by 6. Okay. The acceleration for A and B, A and B are the same. So if we were to say that A equals b is the greatest, then we would go to E. E is next, because E is a very small positive acceleration. And then we have to do the negative acceleration. So which is the least negative? I think we'd have to do F then. And then, do you see how F is negative 1/6? So what I'll do is I'll write them here. So this is 1/2, 1/2. E was 1/6. F was minus 1/6. And then the two that are negative 1/3 are C and D. So C equals D at negative 1.33. Alright, remember on the number line, positive numbers that are large are greater than positive numbers that are small, and then on the negative number line, negative numbers that are big in magnitude are less than negative numbers that are smaller. The acceleration, let's check these here. The acceleration at the marked points is the same, but not 0 for all these boats. False. The acceleration at the marked points is 0 for all of these boats. That's false, because the slope of 0 on a velocity time graph would be acceleration equals 0, and we cannot determine the rank of the acceleration. That's false too, so false. Let's put a false in here. Okay, so that's some practice with some ranking tasks.